All right, hi everybody. This is the Math 31 derivatives review. This is question 13. Find a and b such that y equals x squared plus ax plus b has a slope of negative 2 at the point 0, 2. This is an interesting question. The reason I say that is because the question is saying here, I mean, I got to find a and b, but then the emphasis here is on it's got a slope of negative 2 at that point right there. So they're really suggesting a derivative that kind of immediately, the language of this question is kind of suggesting the derivative, take the derivative, set it equal to, and so on. However, it's important to note, in order to answer this question, that there's a piece of information that's being given here that's basically being kind of slid. They're trying to slide it by you to see if you're really paying attention. And it's the fact that it goes through the point 0, 2. This function right here goes through the point 0, 2, meaning when x is 0, so 0 squared plus a times 0, plus b, the y-coordinate is 2. Well, that immediately means that b is equal to 2. Okay, so oftentimes people will do like the work and they'll get stuck just trying to figure out what that b is because they forget that that's what that little bit of information is telling. Now, when I take the derivative here, okay, I've got, now whether or not you remembered that b, or you're able to figure out that b was 2 here, when you take the derivative of this function, b is a constant regardless. So it is going to be, the derivative is going to be 0. The derivative here is going to be 2x plus a, and then the derivative of b will be 0, regardless of whether or not you figured out that it was 2 or not. Okay. Now, we know that this thing has a slope of negative 2 at the point 0, 2, meaning when x is equal to 0, that's the slope is 2, the first term goes away, and we find out immediately that a is equal to negative 2. And so there it is. There's the information. One, I find by just plugging that point, realizing that when I asked you for this, or suggested that the slope was a certain value at that point, you needed to make that jump and say, the function is going through that point. Okay, plug that in. And then the second one here was simply about just taking the derivative.